Hey, how's it going? Hope you're doing well. I just wanted to show you kind of how a solver works. We have the rubber toy, we have rest, which just stores rest position on the points, turbulence, uh, mob shape fall off, which just gives you that fall off. It's going in this direction, so this is 0, and then it's going this way, and then I'm cycling it back to go this way to show you that in the solver the values will accumulate, or like stay. It does whatever you tell it to do, but um, typically like it's going to keep this value here. It's not going to go back to blue, essentially. So here we're creating the mops fall off. It's called mops fall off as the attribute. I don't like that, so I'm just calling it fall here, renaming it. Here we're just putting p back to rest, which is why we stored this before, so we could noise it up, do the fall off, and then put it back. And that way you get like a more noisy look. Like if you disable it, you can like really modify it, obviously. Like, oh, that's cool. Let's do that. So in the solver, here's a few things you can do. You can grab the fall off attribute. The fall off attribute. You can grab the fall off attribute using this method, the op input one, op input one, and then fall. So one is the next input, or this one, obviously, and then two would be this guy, and so forth. But that requires the point count to be the same. Like you have to have the same exact topology. Um, this doesn't work all the time, but in this case, I'm using it. But obviously, this another way you can do it is just fall and then point number. These are the same things. I don't know why shift down is not working. Oh, there you go. These are the same things. Anyway, so fall max is max fall. So what does that do? So that's saying, hey, during the solve, so we're grabbing the actual fall value, because this isn't updating the attributes. I didn't explain that. This is not updating the attributes. So if I just view this, we just view this output, we're not going to see anything change. Everything remains at 0 because we're just telling it, hey, just output the previous frame. Now if we just output input 1, we're just getting 1, like, or we're getting this input. We're getting exactly what we put in. But when you have your first input on the previous frame and your second input on your input in, you're able to say max to store the maximum value it's ever been. This isn't exactly useful in this situation, but values above 1 or things like that, it can be very useful to have a max. This is pretty often workflow what I use in a solver. So now when you look at it, am I doing this correctly? It's not updating now. I'm not sure why, honestly. Oh, because we're not updating fall. We're not actually updating fall. So you can see I've made a fall max and I'm making a count, but I'm not updating fall. I'm not saying fall equals whatever. So that would make sense why nothing's updating. Okay, so we have a fall max. So you can say fall star here to get fall and then fall max. And then you say if fall is greater than or equal to 0.1, sorry, 0.01, then count plus plus, which just is shorthand for count plus equals 1, which is short for count equals count plus 1. These are all the same. These are all the same thing. So I like to just say plus plus. Just means increment by 1 value. And so here we're not seeing an update, but that's okay. Fall max is now 1. And, oh, that's very concerning. This is supposed to be a tutorial, Tyler. Why is it failing? I'm just trying to show you, like, basically the count. So if fall is greater than or equal to 0.01, count, increment count. And then you can do things like this. So now you can do count. You can see it incrementing. And then if I do my nose, not my nose ring, my node ring, here we're remapping count to count fit. And we're just making 0 to 10. So let's just make it 10. And let's do count star. So now we can see count and count fit. And you can see kind of what's happening. So once this value gets put into 10, count fit is now 1. But before that, it's 0.9. We're basically dividing it by 10. So that's something you can do. And then as the benefit of the system is that as the mops fall off goes back down to 0, it still keeps that count value because we're putting it in a solver. So it's just continuing to keep that same value. Not these guys. These guys are different. But I'm talking about these guys. I'm not going to debug this because this should still be 1 because we are updating fall. Oh. Damn. Okay, it does make sense. Honestly, usually what I do is I just say fall is max fall. And that's usually how I use it, so maybe that'll just fix it itself. Yeah, there you go. That's usually how I use it. Okay, so that's fixed. I don't want to spend any more time than I already have explaining this because I clearly messed up here, so kind of putting my foot in my mouth. So I wanted to show you another setup. So this is one thing you can do. Another thing you can do is point growth or like point propagation. So I don't know, I think you downloaded my infection tool, but inside you can see it's actually doing the same thing. It's a little more complicated. I need to clean this thing up, but we're doing a near point thing here too. What I'm getting ready to show you. So I wanted to show you how this solver is working. So if you turn on cache and we turn on, I'm going to get rid of this. Infect, I want to show you this. So this is infecting based on this sphere, which while I'm here I want to show you, if you click on the sphere and then hit enter to go in the viewport and you click this on, you can middle mouse hold down the middle mouse button and actually it'll snap to the geometry. So even if you're like, let's say your sphere is like way over here, like you can't even see it. You don't have to like find it and like move it over here. You can literally just turn snapping on and middle mouse click and it'll put it there. I discovered that a few weeks ago and it blew my, I'm like, oh dude, it was an accident. And yeah, it's a huge time saver. So yeah, definitely do that. So here we're just grouping inside the sphere. We're saying infect is 1 if it's inside the sphere. And then I can show you both ways. I'll show you the solver way first. And then I can show you the feedback way. So the solver way, all it's doing, so we have that infect attribute 1 equals 1 if it's inside the sphere, and all we want to do is grow that like this. So all it's doing is we're running it over infect is 0, so it's looking at all the purple points. So every purple point it's going to run this vex over. If it's not purple, it's going to ignore it. yeah, if it's not purple, it's basically going to ignore it. If it's pink, it's basically, if it's infected, it's basically ignoring it. So, which means as the solver moves in time, it's actually going to be faster and faster and faster because you're running on less points over time, if that makes sense. So anyway, we're doing, this is a very basic near points function. It just grabs all the nearest points based on this radius and how many points you want to grab. It stores that into a temporary array we're calling points. Remove value points point num. What this means is we're telling it to remove specifically the current point, because every time you do this near points, it always gives you the current point number. We're just saying to remove that, so that way it doesn't count in the algorithm. Like, you don't want it to count in this function. You don't want to include it. You want to get its neighboring points. You don't want to get itself. That just, it's confusing, and but just, this is what you do. And if you get my tool, I don't know if you have it or not, but you can just do that and then hit near points, and it pins to your current vex snippet. So I can just say it's get near point, and it'll do that. That's what I like about my tool. I don't think recipes appends. I think it just replaces. Like if I do this, I don't know what that was. Oh, okay. Anyway, yeah, I don't know what that was. I'm not doing that again. So yeah, so we're moving point, and then we're saying for each int point is points. You can look up how a basic for each loop works, but this is saying this is your representation for the object going into the for loop, and this is the array we are running over. And then we're saying get the infect value from the neighboring point. So essentially we're saying if your infect is 0, so for purple, I wish there was a way I could like easily show you. Let me do that. So let me kill off all of these guys, and just to show you, much better. So now you can much easier see what's going on. So if it's not infected, so it's looking at that purple point, it's saying, okay, give me all the near points within this radius and give me 9 points. So it's looking at a radius around this particular point, and it's saying, give me, if you can find 9 points, give me 9 points in this unit away around this particular, let's say this point here, point 3,999 or 90. Find me all the points in there. Give me its infect attribute, and then we're saying if the neighboring infect is greater than 0, so basically if it's 1, then make my effect infect 1. So now in the next frame, this guy's going to be infected. See? That's it. And then we just keep going, and it just keeps doing that over and over and over again. Now the same is true for a solver. I can put this same setup in, not a solver, sorry, in a feedback loop. This is the same thing. It's actually a little bit more simple in a feedback loop. So here we're doing the same algorithm, but instead of frames, which you can do it with frames, like this, you can do it with frames, but we can just say 100, and it'll just infect the entire thing. Or you could say not 100, you could say 50 or whatever. And you could even there's actually a stop condition, but that's a little advanced. You can actually tell it to stop once all the endpoints get infected. Whatever, let's just do it. It's not that hard. So call it a bool for boolean. We're making it a boolean. And we're just going to say endpoints is equal to, what's it called? Point group. And then points group. There you go. Returns the number of points in the group. So 0, in fact. Now we currently don't have let's run over detail. We currently don't have an infected group, so what we're going to do is in here, once it gets infected, we're actually going to apply it to the group. And that way it will work. So this is a stop condition. It's going on detail. So once all the points in the infected group match the number of points that are going in, 57,000, then this boolean will be true. So if we look here, and oh, some of them are still not infected. Hold on. Hang on. Group infect 1. Let's make that equal true. And now it's true. So we had to make this group 1, 2, not just this. Now it's true. So now what we can do is we can grab this bool value and we can put it in here. And for that, I'm just going to make sure this is compilable. I'm just going to say detail -1 to get that wrangle. And bool and index is that. Okay. And now you can see how many times it actually ran. So 95 iterations. It ran for 95 iterations and then it stopped. So now you can say 300 million thousand and it only runs 95 times because that's all it needed to actually complete the loop. So that's something you can do. Stop condition. Actually, we might have to put this over here. I don't know why it doesn't end up being 1 on the exit. I think maybe that's because it's because I'm doing it with this -1. Maybe if I say bool, maybe it'll work then. No. I don't know then. Because this should be 1 when we exit. But it's not. Calling it infect, right? Yeah. Yeah, we are. I don't know. Anyway, so that's something you can do. Also, while I'm here, I want to show you on the solver node. You see how it's caching that blue? You can actually cut that off. And this works for all nodes, actually. Solver, any kind of solver. DOP node, smoke sim, fire sim, water, anything. You can cut the cache simulation off on your .NET, like that, and it'll live update. So anything you change in here, like if you change the max points, you can see it live update. This is super duper useful for stuff, obviously. See like, oh, is this cache actually working? Like if you want more of a fractal pattern, you can do it this way. Oh, and then you can say, once you do this, once it's infected, you can start the count. So you can say count plus plus. And then that's when the magic happens. Then you can start saying, okay, let's get, where's that? This thing. And we can count fit. And we can start, it's not working actually. I don't know why it's not working. That's pretty cool though. right? Yeah, I don't know why it's not working. Because we're not breaking it. Actually, yeah, we should break it. Why is it not working? Oh, I see. Oh shoot, I see what's going on. So because this is running over infected 0, as soon as it gets infected, it's not going to count anymore. So it's only counting one time. So we need to put this in a different node. So this is infect equals 1. And then we can say count plus plus. And now it should work. And now it should. There we go. And now you can see it working. Hooray, we did it with a fall off. Hooray. And if you shrink this, the fall off will shrink. You can see that there. So yeah, hopefully that helps. You can also do deformations with this, really useful, or like footprints. So if you have, I don't know, if you have Tommy, we're just gonna like animate him. We're gonna pretend like he's moving in space. So let's have him here first, and then let's keyframe him here. I have auto key turned on, that's why this is working. Here, and then here. Okay, cool. He's bouncing up and down. So let's remesh. Let's I'm holding shift to close this in on both sides. Shift. I just learned about that watching another person's tutorial, and I was like, how is he doing that? Mesh. I just experimented, found out. Okay, A to align your nodes. So let's create a deformer for this. So we're gonna use mask from geometry. Set this to points. And click this to visualize. So this is way too big. And sometimes I like to do this so that it really makes sure that it gets it. So we're gonna do this and then this. Okay, cool. And then what we can do is lay down a solver. And we can use that max thing. So let's do that. So let's say max. So let's say mask is mask, the current mask, op input 1 mask. Okay, this is literally how I do it, like often. So you can see what's happening, and then we can just say, hey, we can just say, actually, there's a few ways you can do this. One is with a meta ball. Basically, when this works, there's a magnet you can do. Essentially, when you plug these together, you can do a magnet and it can do that, but that's not really quite what we want. See that? So the idea is like, I guess the idea is like, you could technically copy to points, or like scatter based on, yeah, you could do that. You could scatter based on mask. So you could say scatter mask. You can do like this, maybe if you wanted. Then you can say copy 2 points, and you could put, if you want to magnetize. God, this is complicated. Okay, this is ugly. Why is it not working? Ah, yes. Shift R to switch, and oh, never mind. That doesn't look good at all. But then, okay, never mind. This isn't working. usually what I do is I just say minus equals times mul times mask. So that's usually what I do, something like that. And then you have that. I mean, that's a basic deformation. Just resolve it. And then you have Tommy kind of sort of stepping on the ground. Kind of sort of. And then you could the thing is you could attribute blur this. Not P, you want to attribute blur mask so that it doesn't push out as much. Turn that to proximity is usually a better idea. And you could even like really fade it out if you wanted to. We can make this radius smaller, and you can cut off cache simulation to see how it's going to look. But yeah, that's the idea. I've done this plenty of times, but this is basically how you do foot deformation. You get the idea. You really wouldn't want, you really just want it on his feet, so you could just like scatter points on here and do it that way. We could really, yeah, that looks better. A smaller radius. That looks much better. He's like really going into it. But then yeah, you could like blur it. Let's cache this. Problem with this method is the more, you obviously don't need it that big, so we can even make it like even smaller. That's definitely ideal, so that when it remeshes, it doesn't have to recalculate a bunch of stuff. And now it's much faster to simulate because you're not running over nearly as many points. I mean, if you want to be all technical, you could technically take. What I also like to do is a bounds. I like to do this in a solver. So to calculate the maximum range that he animates in, I like to do a bounds over him. And then what I like to do is merge these two guys together. So merge this, and then do a bounds. So if you merge these two alone, you're gonna get like a shit ton of boxes. We don't want that. Not only is that very expensive, but that's not what we wanted. So, but the idea is like to do a bounds after this to get like one single node. But ideally what you would do is just take this bounds and put it inside of here. And that way it's way less expensive. So that way it's getting the bounds over the entire animation. This is another great use for the solver. You can also do this in a feedback loop, but this is much simpler. Just do that. Then what we can do is just freeze it on the end frame, Control Shift click, and say 300. This is the thing, and then you say, you make this resolution, say we just want to group based on the ends of here, and then we can promote that to primitives, and then we can remesh only in, and that way we're running on a lot less points. So that way only those points, or you could just blast everything that's not in, and then remesh, and then yada yada, do the same thing. And that way it's very efficient. I'm definitely all about efficiency. So yeah, that's another method you can do for like foot deformation. And you could like add noise to it too. So you could say, like, if you wanted to add you can noise up you could noise up the normal, and that way it so when you noise up the normal, that's getting fed into this when we're adding that. So you could just do that, and that way you can get like a really rugged, like you really want a lot of fine control. Oh, and you definitely want narrow centered, zero centered. You can really like push it in. Although that doesn't look as good. One thing we should do is once we're doing this, we want to make sure that is ABS. So what this does is it says, hey, all my values are going to be switched to positive. So any values that are negative in here, I mean technically you just want this on the Y actually. Any values that are negative in Y are going to be forced to be up. So before it looks like this, after it looks like this, and because we're reversing it here, that's what you want. You want it to be, although that still looks like garbage. Oh, because we're not calculating it. So it's setting it to that. So we need to calculate it first. There you go. There you go. That looks way better. Okay. Because this is saying add, but technically there wasn't any normals to begin with. And when there's no attribute to begin with, this is basically like an set. So you can do add or you can do set always. See, they're the exact same thing because there's no attribute going into it telling it, hey, these values are actually up in Y. And the reason why it worked for this is because it is because it calculates it on the fly. I guess this node doesn't calculate it on the fly, which is unfortunate. I don't know why it doesn't, but I guess it doesn't, unless you say enable post process. I guess you could do that. Either way, I guess this node doesn't pre-calculate it, so you need to create it first. Then it will work. That looks much better. So now we're talking. The problem with this is that it's in world position, so as he's moving, you're seeing well, it actually doesn't look too bad. Oh, right, because we're not actually moving in position. We're only doing this once. So actually, technically, this should be up here for more efficient workflow. Before it's time animated, see that clock? That means this is much more efficient now because it's not having to calculate that noise every single frame. This is correct. This is no, this should be up here as well. And this is correct. Okay. That's like the most efficient you can get, I think. Anyway, so that's that. What else can you do? You can grow VDBs in there. So if you have like a sphere, polygons. I like to have my always display on in here so I can see what my voxel count and stuff is. Very, very helpful. I don't know why a lot of people don't do that, but yeah, you should. We're gonna reshape the SDF every frame. So it's expanding out. Oh no, it's expanding. It's a gobble of goo. And then you can, what's it called? There's like a noise you can do too. Noise SDF. There you go. So we can do this too, but this is expensive. This is pretty expensive. But you can do this. Oh shit, that's pretty cool. Oh shit. That's cool, dude. That is so cool. Honestly, I don't think I've ever done this before. It's crazy. You definitely want to expand this out a little bit so that when it's doing this, that's why you're getting that weird clipping, I think. Never mind. Let's copy this. Let's put it into here. Oh, yeah. Okay. That should help. Man, it's not helping. It's not helping. Activate SDF, yeah. So, like, if I look at this, and I don't do this, it looks like this. So when I do this, it looks like this. Oh, this just cuts it off. So I guess we just need to do it here, maybe? It looks like it doesn't activate it. Oh, deactivate. Yeah, no, don't deactivate it. That should help. Oh, shit. Yeah, that should help. Anyway, you get the idea. That's pretty cool. That's crazy. We're really adding up, though. It's a million voxels right there. But it's fun. It's a fun thing you can do. What else can you do? I mean, I've kind of showed you. I mean, point infections are one big thing. That's a big thing. Things like this, where you want to like accumulate values, are a big thing. PDB growth, if you're into that kind of thing. Yeah. All right, man. Hope this longer than usual tutorial helps in some way. Like, I know I rambled a bit, but hopefully that helps. All right, talk to you later. I enjoy talking to you. All right, bye.